we're going to keep exploring this. So we already know what we do when we have division, but we're going to do a couple of these with the expanded format, and then we're going to see how does it turn out to be with the expanded format and the exponent law, and then we're going to kind of compare. Okay? So if I do the first one with the expanded format, I just have to write a times a divided by a, right? And then what do I turn out with? What's the answer here? A squared. And if I do my exponent law, it's just 3 take away 1, which is a squared. Okay? So you see that if I do the exponent law or if I do the expand and simplify, it's going to match. Okay? Let's look at the next one. So I have a cubed. So that's a times a divided by a times a. If I simplify, what am I going to get with? End up with? A. Just a. And if I do the 3 minus 2, that's going to be just a. All right. How about the next one? A cubed divided by a cubed. So I have a times a divided by a times a times a.
Has to be 0, right?
It's 1. Right? Anytime you divide something by itself, right? If you divide 5 by 5, what do you get?
1.
10 by 10, you get 1, right? A by a, you get 1. A cubed divided by a cubed, you're going to get 1.
But it's not a 3 minus 3 has to be a 0, right?
So your power is 0.
So when you have power 0 has to be 0.
No.
1.
So we'll talk about that. Any number. Pick any number, put it on your calculator. Any number you want.
3.
Think of a number, put it in your calculator, and then to the power of 0. To the power of 0. Any number you wish, from 1,000 to 1,000,000 to 1,200, whatever you want. What do you get when you put to the power of 0? 1. What number did you pick, Sharon?
3.
3 to the power of 0, you got 1. What number did you pick, Tomo? 5 to the power of 0, you got 1. How about you, Antonio? Did you pick a number? Okay. How about you? Rigo? Did you pick a number? To the power? No. So that power? That's a power. 0. Put equal? You get 1. So anything to the power of 0, did you pick a number? What did you pick?
7,049.
And to the power of zeros, what did you get?
1.
1. No matter what your number is, as long as it's to the power of 0, it's 1. Why? Because we just saw that. Because basically, in order for you to get that power of 0, it's you're dividing something by itself, right? So in order for me to get the power of 0, no matter what it is, a to the power of 700, right, divided by a to the power of 700, that gives me a to the power of 0. But because I'm dividing something by itself, that is equal to 1. Okay? So anything to the power of 0, a letter, a number, it's going to equal to 1. Clear? Now, we're going to look at a to the power of 3 divided by a to the power of 4. Okay? So if I do the expanded format, a to the power of 3 is a times a over a times a times a times a. So what happened here is I eliminate my a's, but this time I have no more a's in the numerator, I just have an a in the denominator. Okay? So my answer for this one is going to be 1 over a. Yes? Now let's see what happened when I do the subtraction. A,
Exponent minus 1.
3, take away 4, that's going to give me a to the power of negative 1. Now again, my answers here are not the same. But that does not mean I've done something wrong, right? That means they're written in different format. Let's see if that's going to keep happening. Okay? I've already done these two. So let's see what happens if I divide a to the power of 3 by a to the power of 5. Same thing. Cancel, cancel, cancel. In this case, I have 1 divided by a squared, right? If I do the subtraction, a 3 take away 5, that's going to be a negative 2. So what do you think the relationship here is?
I flip the fraction.
Yeah.
But I have to change the power.
That's right.
Yeah.
So whenever you have a negative exponent, you will flip your base and you change your exponent to a positive. That will form your positive exponent. Okay? So, your base is a. You have power of negative 7. You're going to flip your base because this is a over 1. Right? Any whole number, any letter is over 1. You flip the base, and that will become 1 over a to the power of 7. They are the same thing. We're not supposed to leave our answer with a negative exponent. So at the end, when you end up with a negative exponent, you're going to have to change it to a positive exponent. You're going to have to write it as a positive exponent. Okay? What is this going to be? So if I do the subtraction, what am I going to get? A 3 take away 6, which is a to the power of negative 3. How can I write that as a positive exponent?
So 1 over a.
1 over a
Exponent 3.
exponent 3. How about the next one? If I do the subtraction, it's 3 take away 7, which is a to the power of negative 4. Which is, in positive exponent, is 1 over a to the power of 4. So, remember the 0 rule. Any base to the power of 0 is
Just a question. Is there any power to give me the base 1?
to give you the base 1. What do you mean?
If you exponent, I don't know exactly, I forgot the law. So I think there's law that if you have any power, give you the base 1.
So 1 to the power of any power?
Skip it right
No,
now.
any number. Power 0 give you base 1.
No, I mean to give you the base be 1.
If this is base 1.
Sorry, base 0, I mean 0, not 1.
No.
No?
0 is not, you will never get a 0 with exponential unless you do transformation. No matter what the number is, so a to the power of any number you pick, it's never going to reach 0. It will always be close to 0, but it will never reach that 0.
Okay.
Well, we're going to talk about that tomorrow. So if you guys look at this, you know, with the division law, I have to subtract, right? We've already done this. That's going to give me x to the power of 0. And I know x to the power of 0, anytime I divide something by itself, it's going to give me 1. Right? And then this is going to be 2 to the power of 0. This is going to be 5 to the power of 0. So no matter what the base is, as long as it's the power of 0, you're going to get an answer of 1. Are we good with that? All right. With the negative exponent, I say apply this one last, but I have some kind of rules with this. Okay? So I wouldn't always apply this one last. Okay? So eyes on me for a second. If I have this, right? I wouldn't flip yet. I would do whatever simplification I can do with a subtraction or multiplication or whatever I need to do, right? Then if I end up with a negative answer, then I flip. So this, in this case, I do the subtraction first. So I'm going to end up with x to the power of -7 because I have to subtract -2 minus 5. And then I do y4, take away -3, that's y7. Then because my answer has a negative exponent, then I flip my base. Okay? And only this needs to flip because that's the only one that has a negative exponent. Why are you guys looking at the board like this? What? Last. Okay? But I said I have some kind of rules for this. So in this case, now I would flip it, right, and make this 1 over x to the power of 7, y7, or even better, look at this. Because this is a negative exponent, bring it to the denominator, so you'll have y7 over x7. Okay? Yes. Are we okay with this? So in this case, don't flip until you do your addition subtraction first. Okay? So first I have to subtract. -2 take away 5. That's going to give me -7. Subtracting 4 minus -3. 4 take away -3, that gives me 7. Okay? Then I flip. Now, if I have this, for example, I would want to flip first, then I would distribute my my exponent. So don't distribute a negative exponent. Okay? So for this case, I shouldn't have put it up there. I don't remember what was the question that I just saw. Sure. Okay? Don't distribute a negative in. Okay? You want to flip first, then distribute the positive exponent. Because otherwise you're going to mess up. And you're going to mess up big. Especially when it comes to 3 to the power of -3. Okay? So, my suggestion for this, flip this first. And distribute your positive exponent.
So just only in this case we have to flip first.
If your exponent,
Just only.
the outside exponent that you're going to distribute, if your outside exponent is negative, flip your base first, then do your magic after. Okay? Do not distribute a negative exponent. Do not distribute a negative exponent. Can I say that one more time?
Yes.
Do not distribute a negative exponent. Okay, so here's the thing. We saw here that I have an x to the power of negative 7, but the y was to the power of 7. So the only one I had to flip was the x, right? So what I did is I took it from the numerator and I put it in the denominator. Okay? That's basically what you're doing. Okay? So here's the rule. Take only the base with negative power. Take only the base with negative power. And switch its placement. So, numerator 2, denominator, and vice versa. So, if I have, for example, x to the power of negative 4 over y to the power of 2, z to the power of negative 3. Okay? Eyes on the board? For this to work, what you have to do, the letter that has a negative exponent, you're going to switch its spot. So if it's in the numerator, you're going to bring it down to the denominator. If it's in the denominator, you're going to bring it up to the numerator. Okay? So, you see the x to the power of negative 4? It's in the numerator. So you're going to write it in the denominator with a positive exponent. What else has a negative exponent? The z. Where is it? In the denominator. Where do you have to bring it? Up to the numerator, right? So what happened here is that the z is going to become to the power of positive 3 up in the numerator, and then the denominator, y is going to stay there because it's already positive and happy, right? And then the x is going to come to the denominator, and we're going to make it happy by becoming positive. Okay? So this is what we say by switching its spot. If it's in the numerator, you take it to the denominator and vice versa. Are we okay with this? Yes? Okay. Another thing that I want to mention to you, if you have, for example, a over c to the power of negative 4, okay? Because the whole a over c is to the power of negative 4, for me to make it positive, I have to flip the whole thing. Okay? So that's the same thing as writing c over a to the power of 4. Okay? So whenever I have that big bracket, the whole bracket is going to have to flip.